Good morning, students. So, let me continue the lesson that we have discussed, force and pressure, right? So, we are dealing with the chapter force and pressure, right? What is the force and pressure, right? So, we are dealing with force and pressure, the chapter force and pressure. So, what we have discussed in the last class, do you remember? Have you did your homeworks, means activities that you have given in your textbook? Did you read your textbooks? Okay, you should read and you should do the activities, right? So, what we have discussed last class, we are discussing that the force, we are discussing about force. So, what do we mean by force? A push or pull on an object that may cause the change, its state of motion. We call it as force, right? So, here we apply some force in this box in this direction. So, we already said that force has both direction and also it has magnitude. So, we can call it as force is a vector quantity, right? So, what are vector quantities? That already we have discussed, which means the physical quantities that have magnitude as well as direction are called as vector quantities, right? So, here force is a vector quantity, right? Force is a vector quantity, right? So, what does it mean? When we are applying a force in this direction, suppose it has a magnitude 10 Newton, right? Newton is the unit of force, right? So, we are applying a force of 10 Newton into this box, right? So, it may move a little. So, now the box is here, right? So, when we are applying 10 Newton force onto this box, the box changes its state. That means from here to here, it moves from here to here, right? And if another force of what? 20 Newton, okay, suppose it is 20 Newton, is applying on this box, it will move some more distance, right? So, what actually happened here? These two forces are acting towards this direction, right? So, both these forces are acting in this direction. So, the total force, the net force on this box is added up, right? That we have already told in last class, right? So, what is the net force acting on this box? It will be 10 plus 20, right? So, it will be 30 Newton. Now, the net force acting on this box is 30 Newton. So, it can move furthermore, right? So, maybe the position of box may change from here to here, right? So, these forces are acting in this direction. Both the forces have same direction, so it will add up, right? And we can see another situation. Right? You can see another situation. a person applying a 10 Newton force into this box in this direction, right? And another person from here is applying 20 Newton force in this direction. So, what happens to this box? Does it change its direction? Can it change its direction? Yeah, it may change direction. It may change the position of this state, right? So, can you say how it moves? How the box moves? It moves in this direction or else it moves in this direction. What will be the direction of movement? Can you say? So, we can see that here the magnitude of force in this direction is 10 Newton, right? And the force applying in this direction, right, which means the direction opposite to this force, right, is 20 Newton, okay? So, what will be the net force acting on this box? What will be the net force acting on this? It will be the difference between these forces, okay? These forces are in opposite direction. So, the net force will be equal to, suppose it is F1 and it is F2. The 10 Newton force, we can write it as F1 and it will be F2, right? So, the net force will be the difference between the two forces. So, what will be the net force? 10 minus 20, right? So, what will be the net force? Minus 10. So, minus 10 Newton, okay? What will this negative sign indicate? This sign indicate the force acting in the negative direction, okay? That means the box will move in this direction, okay? So, that is because of the force is a vector quantity, right? The force will move in a direction that is much more force is applying in this direction compared to this. So, the box will move in this direction. This negative sign indicate only the direction of the force, right? So, that is force has both magnitude as well as its direction. So, it is a vector quantity, right? These all things we have already discussed, okay? You just remember all these things, okay? So, now we can go to another question, that is force is there any change in object, is there any change in the state of motion of an object when we applying a force? Already said that when we are applying a force into an object, it may change its state of motion, or we can say a force can change the state of motion of an object, right? A force can change the state of motion. So, what do you understand from state of motion? What do you understand by saying this term, that means state of motion? Does it says only about a moving object? No. Here you have in your textbooks, it is described that the state of motion of an object is described by its speed and the direction of motion, okay? And the state of rest is considered to be the state of zero speed, okay? And an object may be at rest or in motion. Both are its state of motion. Okay, let's know. Suppose here is a ball. Here is a ball. Suppose it is a football, right? So the ball is at rest now. That means the speed of this ball is equal to 0, right? When we are talking about the state of motion of an object, both the state of the object like the state of rest or the state of motion, both of these are state of motion. Okay, that is, when the ball is at rest, it has 0 speed, right? And if we kick the ball by your legs, then the ball start to move, right? Then the ball start to move in this direction, right? So what happened? When applying a force, this ball ready to move. Okay, this ball comes to move, started to move, right? So the speed of this ball changes, right? The speed from 0 to some speed, it will increase, right? When we are applying a force, the speed of an object will increase so that it can move, right? So take another example of a car. When we are say a car, suppose suppose I am not good in drawing. So suppose this is a car. Okay, I don't know how to draw a car. Suppose it is a car. So at first this car is at rest, and we are starting. Before starting the car, the speed of this car is 0. Okay, when we are starting the car and it at first it comes to move at a slow speed, right? And if you are applying more force on the steering, or it can move more faster, right? So the speed of car will change when we are applying more force, right? These are some examples. When the speed of an object is 0, then we call it as the object is at rest. And if the speed increases by applying an external force, it will start moving, and then we are saying it is in the state of motion. And also we can say the speed of an object increases while applying a force. So that is all about state of motion, right? It's not only the state of a moving object, it's also, we can say, the object at rest is also its state of motion. That means the speed of object is 0 when it is at rest. So both these are the state of motion. Okay. So what we have from here coming, we just started a force can change the state of motion, so that when we are applying a force, the state of motion of an object may change. So we might recall some similar situations. For example, suppose the already discussed example, when we are kicking a football with suppose it's going to take a penalty. Okay, you all know what is penalty, right? So when a player kick the ball towards the court, the force applied by the player on this ball, the ball will move towards the court, right? So there is a change in state of motion of the ball, okay, and it will reaches to the goalkeeper, right? The keeper catches the ball. What happens to the ball? It will suddenly stops, right? So there also happens a change in state of motion, right? So at first the ball has 0 speed, and when the player kicks the ball, it start moving, or it has some speed, and if the keeper catches the ball, then what will happen? It will come to rest, right? So all these situations, what all these situations says, that means the player has to do some force on the ball to move the football, and also the keeper has to do some force, exert some force on the ball to catch the ball, right? So all these forces can change only after applying this force, the ball changes its state of motion, right? So that means the applied force on the ball changes its state of motion from rest to moving, and again to rest, from moving to rest, right? So these observations suggest that a force applied on an object may change its speed. You should underline in your textbooks, that is in page number 131, right? There these observations, what observations? We already discussed observation, right? As in the case of the football, and these observations suggest that from here you should underline, force applied on an object may change its speed, right? Force applied on an object may change its speed, right? If the force applied on the object is in the direction of motion, the speed of the object increases. That means if suppose what I should say, suppose a ball is moving in this direction, right? Suppose a ball is moving in this direction, and here the ball, it's moving somewhat slower in this direction, okay? Then one player kicking this ball in this direction also, right? If the ball is moving this direction and the force applied by the player also in this direction, then what happens to the speed of this ball? The ball moves more faster, right? So the speed will increases. Speed will increases. Okay? If the applied force is in the direction of the motion, then the speed will speed of this object will increases. Okay? So you should underline these things. Okay. Suppose if the force applied in the direction opposite the direction of motion, then what will be the result? What will be the result? If that is we can explain that in the case of what? The goalkeeper catches the ball. That means the ball kicked by the player is in this direction, and here is the court, and here is the goalkeeper, which means we simply call it as goalie, right? So here the keeper applies a force in this direction. When the ball is here, he catches the ball by applying a force in opposite direction of this motion, right? So then it will comes to rest. Okay, while catching the ball, the keeper applying a force which is against the direction of the motion of the ball, right? So what will happen? The ball comes to rest. The ball comes to rest. So if the applied force, the direction are opposite in direction, then speed will decrease. Speed will decreases. Okay. So what are the so far we have discussed what are the effects of a force on an object, right? But what we have said, the force applied on an object may change its state. We said that the state of motion of an object may be described by the speed of the object as well as the direction of the object, right? So a force can change not only the speed of the object, it can also change the direction of a moving object, right? So there are some another examples. Suppose while playing volleyball, or suppose while playing hockey, right? So while playing these games, the ball may change its direction from one court to another and from one player to another player, right? So while applying the force by the players, the state not only the state of motion, which means not only the speed of the ball, but also the direction of the ball changes, right? So this all example says that a force can change the speed of an object and also it can change the direction of a moving object. So here you have some more examples in your textbooks, and you should read carefully and you should underline the things that you have given here in your textbooks. That is, I can read that a change in either the speed of an object or its direction of motion or both is described as a change in its state of motion, right? So while applying a force, either it could change the state of motion, that means a moving object will come to a rest, or a object at rest will start to move, or the speed of object may change and also the direction of the motion changing, right? So you should underline these things. That means a change in either the speed of an object or its direction of motion or both is described as the change in its state of motion. Thus a force may bring a change in state of motion of an object, right? So this is the conclusion what we have discussed so far, right? So you should underline that a force may bring a change in the state of motion of an object, right? So does it mean that the application of force would always change the direction or the speed of the object? Do you think it can only change the state of motion, which means a force can only change the state of motion of an object? Do you think what are the other effects of force? Think about it. And there are some more effects by an applied force. Okay, so What are the other effects? A force may change whenever applying a force on an object, it may change the shape of an object, right? It may change the shape of an object. We can discuss more examples for this category, right? What means? That means force can change a shape, the shape of an object. We can discuss some more examples, and through these examples you can clear all these things, right? So we are wind upping this class. So what we have discussed today? We have discussed what is the state of motion of an object. That means, what is the state of motion of an object? It is either the change in speed, either a change in either the speed or the direction of motion may cause either the change in either the speed or the direction of motion may cause the change in state of motion. State of motion of an object, right? Okay, or both these, okay, or both this speed, either the change in speed or the change in direction, or both may cause the change in state of motion, right? And what else we have discussed so far? The force can bring a moving object to rest, or a force can what does a force can do? Force can do what? It can move. What else we can say? It can move a stationary object and what else? It can move a stationary object and can change its position, right? And what else? It can also change the speed of moving objects, right? Can change. Force can change the speed of moving object, right? Moving objects. So it may be like what? The speed may increase. Or sometimes it will decrease by applying force. If more force is applied, then the speed will increase, and if lesser the force, it will decrease, right? So these are the things what we have discussed today. Okay, so in the next class we can discuss how a force can change the shape of a object. right? So, in the next class we can discuss how force can change the shape of an object, and here you have more examples in your text, and we can discuss more and more in the next class. So, today we are wind upping and we can see in the next class. Okay, goodbye.